Ever tried solving a puzzle where every move you make creates 1,000 more possibilities? Like planning the fastest route for a delivery truck hitting 50 cities. That's what combinatorial optimization feels like. Overwhelmingly complex, computationally intensive, and frustratingly hard. For decades, experts have relied on human-designed rules of thumb to tackle these problems. But what if we could let AI do the heavy lifting? Today, we're diving into a groundbreaking approach called HeurAgenix, which uses large language models to revolutionize how we solve these puzzles. Let's break it down. At its core, combinatorial optimization is about finding the best solution when there are incredibly many options. Think of it as searching for a needle in a haystack, but the haystack is constantly growing and the needle keeps moving. Traditional methods use fixed strategies, like a chef following a strict recipe. But recipes are rigid. They work for specific dishes, but fail when ingredients change. Enter HeurAgenix. This system uses a two-part approach. First, it evolves heuristics, problem-solving rules, by analyzing solutions. Imagine training an AI to compare delivery routes. It notices patterns, like which shortcuts save time or which paths avoid traffic, then turns those insights into reusable strategies. It's like teaching a robot to refine its own recipe through trial and error. But here's the real twist. During problem-solving, HeurAgenix doesn't stick to one rule. Instead, it dynamically picks the best heuristic for each step, like a flexible chef adapting a recipe based on what's in the fridge. This selector can be a powerful language model or a lighter, faster version, giving users control over speed versus accuracy. Now here's the challenge. Real-world data is messy. How do you train a system when feedback is noisy or incomplete? HeurAgenix tackles this with a dual reward mechanism. It learns from two signals, what works like successful routes, and what the problem looks like traffic patterns. This dual perspective keeps the system robust, even when information is shaky. Let's take the traveling salesman problem as an example. Imagine you're a delivery driver, needing to visit 10 cities in the shortest possible route. Traditional methods might guess randomly, but HeurAgenix evolves smarter strategies. It starts with a basic idea, like picking a random city to begin. Then in each evolution round, it gets smarter. Round 1, it picks a central starting point based on average distances. Round 2, it weighs both immediate and future costs, like planning a road trip with gas prices in mind. Round 3, it tests where to insert a new city into the route, balancing short-term and long-term gains. Round 4, it narrows down candidates to only the most promising options, like filtering recipes by ingredient availability. Round 5, it fine-tunes the route using a two-opt method, swapping parts of the journey to save time. But how do we know these strategies work? That's where the Monte Carlo Evaluation strategy comes in. Think of it as running a recipe through 1,000 taste tests. The system simulates the heuristics performance across dozens of problem scenarios, measuring how well it performs. The result? HeurAgenix consistently outperforms traditional methods, especially in complex problems with tricky constraints. What's even cooler? It's adaptable. Unlike one-trick ponies, HeurAgenix can tackle multiple challenges, like delivery routes, job scheduling, or packing problems, by transferring knowledge from similar puzzles. It's like a universal puzzle solver that gets smarter with practice. So what's next? As AI continues to evolve, tools like HeurAgenix could transform how we tackle some of the toughest problems in science, business, and beyond. Imagine faster delivery routes, more efficient manufacturing, or smarter logistics. HeurAgenix isn't just a tool, it's a glimpse into the future of problem-solving. Thanks for watching. If you enjoyed this, hit subscribe for more explorations into the fascinating world of AI and optimization. See you next time.